The first part is really the sort of basics of propagation. If you look at this here, this is indicating a low frequency. Typically, if you talk about the cellular bands, this would be around 900, 800, 700 megahertz. You can see that the frequencies will increase on this side. Now, if you look at the sort of scenarios, we typically find that people use these low frequencies in the rural type of environments. The reasons for that is quite interesting in the sense that these frequencies penetrate bushes, vegetation, and they also give you longer distances. So if you look at the coverage, typically the coverage is sparse in the sort of rural areas, but because you're using the low frequencies, you can get better distances. So cell density is low, and of course, fortunately, you also don't have too much people accessing. So capacity is not a big issue because the bandwidth here is also fairly low. So as you go up in the spectrum, if you get to the city type of environments, people would typically be using 1700 up to most probably 3 gigahertz in terms of the type of frequencies using in the LTE type of systems. The problems with these frequencies are that certainly the cell densities get very high. They have to, because for these frequencies to get into buildings is very difficult. So you need to have something that's almost line of sight of you in order to get in. Indoor coverage becomes pretty disastrous. They don't penetrate things well. And we'll show you a lot about that a little bit later. The other aspect is that capacity there becomes an issue. So most of the problems that you find is because this cell base station don't have the capacity to handle all of the data that's required. And that's one of the areas where external antennas help a lot because you give the cellular operator a much better spectral usage. So you can steal quite a lot of his capacity. He's going to prefer serving you to other users that's accessing the network at a very slow data rate because of a low signal to noise ratio that they will have if they don't have proper antennas installed. If we look at the radio propagation and environment, and this comes from many questions we've had over the years, we're going to discuss rain at some point. People always wonder about trees, foliage. Of course, this is the nice situation where you've got a guy standing outside and he's got line of sight. And then what you typically find is if the guy's inside a building or inside a house, the signal will drop very rapidly. And we find that drop that you get, that you see over there, roughly about 16 dB in total. Because not only a drop in signal in terms of penetrating, it's also a lot of multipath, because the higher frequencies will pass through the windows, doors, and so forth, but they will reflect and, in a sense, make the reliability of a connection with antennas indoors very bad. So getting outdoors, certainly in these cases, is a massive, massive advantage. If we look at the clutter elements, and I think this is a very, very important slide, once again, just because of the questions we get related to these aspects. Which are the things that really cut down on signal? In other words, stop a signal from penetrating. The most, what do you call it, severe effect, and we've measured this, is reflective glass and double glazing. I'm talking here about your typical office buildings that got the gold coatings, and they're actually metal coatings on that glass, and you virtually get no penetration. So you still get penetration into the buildings, but that's, like I always say, via the cracks, nooks, and crannies. So that's really a severe effect. Bricks, concrete, rock, metal, of course, is a big block to the signal. Then, and this I will discuss in a lot of detail, and trees close by has a severe impact on signal strength. That doesn't mean that trees in general is a big problem, and I'll get to that a little bit later. Normal glass, dry hollow walls, not such a big impact. In other words, if you look at these aspects, you'll get a number of dBs lost. You still suffer from the multipath once you're inside, but the penetration is actually not too bad. Then you've got trees blocking line of sight. They're actually not too bad, and I'll show you later why not. In other words, if you've got a a heap of trees in between you and the base station, but they're not very close to either the base station or yourself, there's actually a fairly good penetration, and we've both measured it and it's known theoretically. Then this is a question I often get where people say, rainfall, does it impact on communication? Now I can tell you, if you're below 6 gigahertz, which is the upper ISM band, and lower, rainfall's virtually got zero impact on communication. The reason why some people do find some impact is if you do have trees in the way, the tree absorption, because there's a lot of water on all of the leaves, that does increase. But rainfall itself, you don't have to worry about. It's almost the equivalent of free space, especially over small distances. It becomes a big impact at about 10 gigahertz. So that's why your satellite TV really suffers when there's a lot of clouds and rainfall in the area. Here we get to the tree story. And this was actually something that surprised me in the sense that people have found that if you look at a number of trees, say in the middle of a link, you do find that much of the propagation is sort of by reflections, and that's in between the trees, below the trees, through the tops and so forth. And you get to this side, and we, for example, have measured over, say, 300 meters, and there's a nice little article on the LinkedIn profile that we can get 100 megabits up speeds at Wi-Fi, in other words, about 5 gigahertz, when we've got up to 60 meters of trees in the way. But then they are in the middle of the link somewhere. What happens here is, of course, since these propagation modes are going around the tops, bottoms, and so forth, if you've got trees very close to the house, you actually do get a severe impact of that. So it's quite important that if a tree is, and I'm talking here close by, a few meters away from your antenna, then that tree is no longer can be neglected because the penetration through the actual leaves is not at all good. Here we look at the obstacle clearance. Now, people talk of line of sight, okay, and that's of course important. Most of these high frequencies, people say you can get good communication if you're in line of sight. Now, there is a factor known as the Fresnel zones, and we can give you equations to work out what's that sort of width of the zone, and that has to clear the obstacle. If the obstacle is actually sort of in the Fresnel zone, and these zones depend on the distance between the links as well as the frequency, then it starts having an impact. Not severe if it doesn't actually block the line of sight, but roughly speaking, you could get sort of 3 dB reduction in signal. If the object actually blocks your line of sight, then it gets more severe and you get most probably about 15 dB. There's still a certain amount of it diffracted around the object. Now, this is a quite simplistic drawing because you must remember it could also be clearing the sides of buildings. So if you've got a big building in front of you and the line of sight goes very close to the side of that building, it could still have some kind of impact. The one aspect one have to take into account in a city environment, there's also reflections. Reflections can often give you still reasonably good data links, even if you've got a building in front of you, because of course you could be receiving that signal. And when we get to the choice of antennas, you'll see this is quite important. And also when you talk of MIMO, in other words, signals with multiple input, multiple output, this is sometimes quite useful because it can actually increase your data because you've got more than one path between the transmitter and the receive antenna. Here's a little sort of scenario. Here you've got, say, very close trees, and you can see on this side, it's often quite useful just to go further away from these trees. Of course, going up is also useful, but just moving further away from them gives the wave time to expand and get through, like I say, the gaps and so forth in the tree. So as counterintuitive as it may seem, it's quite good to sometimes move back, and it's typically always good to move higher. Here's another instance where part of the house could actually be cutting off the beam of this antenna. Once again, you can actually move it there just to make sure that you've got a clean beam facing the base station. And of course, that part is still cut off there, and much better to get it so that within the beam of the antenna, and we always publish the beam width, you've got no part of the house or the building obstructing the signal. Best is, of course, always if you haven't got obstacles, you can actually just go on that side of the house that faces the building that faces the base station. This is an important one just because, once again, we get lots of questions. In the olden days, we only looked at signal to noise ratio, and that's effectively the amount of signal that you get on your side relative to the amount of interference or the noise in the receiver itself. Lately, with LTE, you'll see two factors. The one is called RSRP, reference signal received power, or RSRQ. This is because if you look at LTE and these signals, there's actually multiple channels, close to 100 channels getting transmitted next to each other. And this looks at that complete picture. So typical signal to noise is not good enough anymore. And I think these are excellent reference values. So you need to get all of these, but mainly these ones if you're looking at the LTE signal. And these are indicators of what would be good, excellent, mid-cell, and edge cell, and some relationship. But what I do want to note is that you could get this guy, say, in a good value, but if you've got the RSRQ or the RSRP lower, then you actually do still have a problem. So they're not necessarily directly related. And I would focus on these two, and they are directly related. So if one or both are good, you typically have got a good link.